Hi, and welcome to this quick tool review. This time around we have some interesting tools that are new additions to my shop, and I think you should enjoy them. First up is this used high-speed spindle grinder from NSK. It comes in this package as is. It comes with an air regulator and an auto oiler built in. It has a 3/4 inch shank and a 67,000. This is a Planet 550 rotary grinder. It's fairly high speed. They make a newer version, the 600. By the way, this older 550 is old enough now that they don't have a whole lot of parts for it. So when this dies, it's pretty much gone. They're on the Planet 600 now, I believe. It has a really neat feature, so the air coupling in and out. By the way, the reason why it has a separate air output is they have their own exhaust system that mutes the noise. So this makes it nowhere near as loud as it would be otherwise. Plus it catches oil droplets that are in that stream, which is very handy. Another nice feature about this is the air in and out is on a swivel. So you see that the main body will rotate. So I can take this guy and I can mount this in a boring head, and the boring head could be going around like this while the hoses don't have to obviously rotate with it and get broken. So you can bore and do very accurate holes, grind a hole to extreme precision if you want with this. This is the poor man's version of the Moore jig borer. So I picked one up. You can also, besides in the milling machine and a boring head, you can use this guy in the lathe in the tool post. So you can either go this direction or this direction and use it as a tool post grinder. I have a normal tool post grinder, but if you want to do really small stuff, the smaller diameter you go, the higher speed you want to go. This is a good solution for that. This one came with a number of attachments. I'm not quite sure why it came with the router bit. That's kind of unusual. It's a dovetail cutter there. Came with a few stones and some other, a quick adapter. That's kind of interesting, probably for to go on there. I'll fire this guy up so you can hear what it sounds like. It's pretty impressive when it speeds up. It's nowhere near as loud as you might think it would be. So right now this guy's set at about 50 psi with the pressure regulator built in, and you can just turn the valve on here to get it going. One downside to these is that they take a fair amount of air volume, so my compressor will probably turn on pretty quickly. Very smooth bearings. I did get one of these. There was another one that was selling for like $100 and something, and I got that one to get as spare parts, since you can't get these anymore or have them repaired very much. But unfortunately the bearings were totally shot in it, so I sent it back. But I'm very happy to have this one and very excited to use it, and hopefully we'll see it in upcoming projects. So this is an NSK Planet 550. Steve Barton, I think, has the latest Planet 600, if I remember right, and he demonstrates it over on his channel, Solid Rock Machine Shop. Go check it out. He does some amazing precision work. I hope to get there myself someday. He's one of my inspirational YouTube mentors, that Tom Lipton, Joe Piezinski, Robin Renzetti. Always more to learn. That's what makes this field very interesting and enjoyable to stay in. By the way, the NSK grinder uses its own special lubricant, Saperla 9. You can buy that in 55-gallon drums, but finding small containers is tough unless you go to NSK directly, in which case they kill you on the price. But you need something that's the right viscosity, or the air motor won't work properly, and if it's too light of viscosity, I guess you could damage the air motor, so you got to get it right. Next up, we have a tool that I bought out of pure curiosity, only because I was curious if it even worked. It is a really unusual idea, and I haven't seen it before. I would think that if it was a really good idea, we'd see a lot more of it. Maybe surface grinder is just a lot easier, but this is called the Super Finisher Mill Kit. And this kit was new used, or new old stock again, but it looks like all of their lubricant that came with it leaked out into the container inside here. I can't even get them out. Oh, there you go. Oh yeah, they ruptured nicely and leaked all over the place. So that's lovely. It's a very unusual design. So it basically has 2 grinding wheels, and you put this in your milling head and you rotate it around. And since the wheels will have the outer diameter move at a higher velocity than the inside diameter, they're going to cause it to rub and interfere with the material and therefore remove material. I don't know how well this thing works at all, but we're going to take it over the mill and give it a shot and see how it works out. You can tell just how old this thing is. Look at the safety glasses. The plastic lamination on it's completely disintegrated. It's very amusing. So anyways, came with the manual, and we thought we'd give it a shot. It supposedly can make extremely fine surface finishes on the mill without a surface grinder. So we're going to read a little bit more about it and get over the mill and try it. This kit comes with ferrous grinding, non-ferrous grinding, and polishing. There's non-ferrous and ferrous polishing, but the non-ferrous grinding doesn't require coolant, so we're going to go with that one first, less messy. The wheels have various lives, but something like 25 to 35 hours. The thing that I'm going to find exceptionally difficult is you need to do your in-feed at amounts that are similar to a mill. So, sorry, as a surface grinder. So if you're trying to in-feed a mill like a 1/10, that's going to be pretty challenging, and it definitely is very sensitive to in-feed amount. If you in-feed too much, you can cause problems. Now, they did say that these wheels, which are not on the center line, they're offset so that they sort of drag on purpose. You'll be able to hear it when they're wrong. And the fact that a lot of this part is plastic apparently is part of one of the features of this thing, is that the little bit of flex you get in the design of this product lets the wheels sit flat and cut flat. So we're going to find out. I think we got a piece of aluminum plate in here that's just simple extruded aluminum plate. And we're gonna try this guy first and see if we can get a decent finish on it. You need to tram your mill, and it needs to be accurate within 6/10 in this direction and this direction. And then after you've trammed it, then you set this down, find your 0 point, and then proceed to go. Let's see how it works. I think this thing might be, one of the problems with it is might be a big bit of a pain in order to use, so much so that some people probably would. I don't see these around, so I'm guessing that's part of it. And maybe it's so persnickety with your in-feed amounts that it's just not practical to do on a milling machine, because how do you raise your knee 1/10? I mean, you can use an indicator to measure it, but the mill's really not set for those kind of fine measurement adjustments. First step to replace the wheels is to take the cover off, which is this guy here. Comes with all the tools to work on it. The threads are left-handed on the shafts to mount the. Okay, so it's an aluminum block to hold the shafts, and they already came loose. Well, that was sort of loose. Nope, I was wrong. Oh, of course I'm trying to go. They're reverse threads, so they said don't over snug them. That's very important. That they need to be just tight enough. I love the just tight enough, because what is that? That's a relative measurement. So I wonder if I could even find these wheels anymore, because the wheels are special formulation that the company had made just for this process, and apparently that's part of the magic. So I haven't even gone and looked to see if this company exists anymore, so you could buy any consumables from them. This might be a one-time try, but I was so curious about this that I thought, what the heck, let's investigate. They did make the fit very, very tight. The coolant you need to use with this is either a synthetic or semi-synthetic, non-milky, clear type of coolant, or it won't work. I'm going to make a note on here for my own notification that these are left-hand threads, because I know me, I'll end up struggling with it and won't be able to figure out why I can't loosen it. Right, so head tram was really close on this mill already, which was great news. It was pretty much dead perfect this way, so this angle. It was almost dead perfect this angle, and it was off by about 2/10 this way, which I corrected, which is well within their spec. I could have just done it as is, but I figure as long as I got everything out, might as well pull it back in. Setting up the tramming on this milling head can be really challenging. The bolt, there are 4 bolts on the front and 3 on the side. You have to tighten them, you know, a crisscross pattern, and you have to be very careful how you tighten them, or the distortion's enough to throw the tram out, which is probably not surprising to anybody, but always challenging. All right, so head trammed in, super finisher loaded, and a 3/4 collet. Next step is to raise the table, and they recommend using the quill for part of it. So they tell you take the quill, touch, and just ease up a little bit, then lock the quill solid, and all of your adjustments of height will be raising the knee. So they tell you, let me get this out of the way here. They tell you to raise the table until it just starts to touch. Okay, and that will be your 0 value. Set my Z knot on the DRO, and then you start off the workpiece. I'm going to drop down just a little bit. It's going to be hard to have a safety shield here. This will be back here. They give you in-feed values for what you're looking for. The RPM should be 1700 to 2500 RPM. So we're going to go for something in the middle of that range, around 2100 RPM. So I'm wearing a respirator during this. So I'm also using a vacuum because I don't know if you could see it, but there was a cloud of material coming off this part. So I'm locking everything off, and I'm going to walk in another 6/10, see how it does. This was not terribly flat to begin with. So it's working surprisingly well, especially considering this is just an 80 grit wheel. One thing is it makes a mess everywhere, as you can expect grinding would do. That's no surprise either, but definitely a reason why you may not want to do this on the mill, because unlike the grinder, it doesn't protect everything as well. So successive passes do clean up the previous pass, so it is doing its job. I haven't been able to get all the way over here. I've done multiple passes. I'm not sure if the grinding wheel's wearing or what. It does put a cloud of stuff up that's just covering everything. So I could see one reason why you wouldn't want to do it would be that alone. So next up, I'm just going to change to the polishing wheel and see what kind of performance I get out of that. Here's zooming you into the finish with 80 grit. It's not bad. And remember, this is aluminum, not hardened material. So some interesting anomalies as it's exiting here as this thing unloads. Do notice some difference in the patterns. You can't feel it, but you can see it. So that's a problem too. You'd have to have a sacrificial workpiece to go off onto, it looks like. So that's another negative right there. Tons and tons of grit everywhere. So interesting to note, the wheel that was loading up more than the other was the nut had gotten a little bit loose. Now they warn you in the manual to be very careful not to over tighten. So I was trying to just do it snug, but it came undone anyways. So maybe that's why the finish isn't better. Could be. All right, so we're doing a pass with the polishing wheel. Now we went from 80 grit, which is crazy. They sell grits, a whole range of grits. So we're probably going to polish the high spots of the grind of the 80 grits. It's probably not a fair test doing it this way. Well, that's interesting. Sounded like something kind of just got hosed. So I will say to the touch, this finish is glass smooth over here. Where it initially bit, not so much. That's not good, but this actually is a glass finish. They do say this process, you need to really dial it in. I think we lost a wheel or two. Huh. No, they're still there. I'm not quite sure what happened in the scale things. I'm going to try just one more pass. I'm going to dial in a little bit more. I can say one thing is that it doesn't like being unevenly loaded. It doesn't perform the same. So how you go off the end of the piece probably is a bit of a trick. The finish with this polishing one is surprisingly smooth. It's very impressive, actually. But I think this thing generates way too much mess to want to ever use in a practical sense. It's a really interesting idea, and it actually has a US patent associated with it. So that's the super finisher. Here's the finish I was able to get. You can see parts of it are very, very nice. Parts of it not so much, especially when it leaves. This is where it plunged in just a little bit. You can't actually feel that, but you can see it. And then when it leaves marks on it. And if you have one, and then when I came from here down to here, so it'd try and get this area, as it went off the side, it loaded differently and marked it. So I don't know. My feelings are this is an interesting idea, but it probably takes a lot of practice to get any decent results out of it. And anyways, generates way too much crap for the mill. Little particles of stuff all over the place, probably abrasive too, definitely not good. So I'm going to have to clean everything very nicely before I can use the mill again. So interesting experiment, but I give it a thumbs down. One last thing, check the glazing out on the polishing wheels. Look like they're mirror finished now. They loaded up quite a bit, one much worse than the other again. Oh, and it's interesting, it kind of ran in, even though the washers have spacers, they kind of ran into the plastic, and it feels like one of the wheels self-loosened. Actually, both of them self-loosened, no kidding. And I tightened them more this time, so that's probably another part of this problem. I don't know, pretty bizarre. For a long time, I had this heat gun. It still works perfectly well. You've got a cold setting where it just blows air, and hot. You adjust the heat by restricting airflow going over the coils in here, the heating coils. Even all the way closed, it still has a little gap, so it allows some air through. Lets you set temperature fairly and accurately. The thing is really big and bulky. If you want to use it by hand, it's designed to be used on a bench, mostly for things like heat shrink tubing, and it works fine for that. But I wanted something a little more portable. I was over at Harbor Freight, saw this and thought, what the heck, I'll check it out. Supposedly 120 to 1200 Fahrenheit, 108 temperature settings, which is kind of a weird arbitrary number. But this one does look like it has a digital interface on the back that supposedly reads the temperature. I don't know if they measure it or they estimate. So let's pop this guy open. Just so you know, they're claiming it is 17 cubic feet a minute, 14 amps, 1700 watts, 10-foot cord length, and 2.5 pounds. So a heck of a lot lighter than that cast beast that I had before. So there's the contents of the package. The gun's bigger than I thought, but not too large. Comes with 3 different nozzles. That could be handy. They are just stamped in pressed metal, so nothing to write home about quality-wise. They look like they'll work. They're functional. Yeah, just pressed on. So reduction nozzle, a flat flaring nozzle, like if you're going to do glue, sheets of glue or something, and a scoop to protect something that can't take a lot of heat from the main heat blast. It's got a really good hand feel, very comfortable in the hand, and it has some settings on back. Looks like temperature up and down, fan up and down, cold and power. Very straightforward. It's got a hook to hang it from. They've got a gooey overmold on it, which is pretty nice. Feels really comfortable in the hand. Very flexible cord. 14 gauge wire. Seems kind of light for 10 feet, but they probably had it checked out. Is this thing UL listed? It is UL listed, so I guess that must be okay. I wonder if I use this for any period of time, that's going to get hot. All right, so power. Fans all the way up. And we can take the temperature up. Push and hold and it goes up quickly. We'll just head out here to max. Gets hot fast. Oh, and it appears to read the temperature, current output temperature, which is really handy, if you can see there. So initially when you're setting the temperature, it tells you what you're setting it to. And then if you wait a little while, it tells you where it thinks it's at. That's really handy. And you can jump to cold anytime you want. They don't let you see the coils. They've got a pressed piece here in the end that causes the air to rotate to create vortices. That'll let the heat distribute better on things you're blowing it against. It is a fairly inexpensive stamped end. All right, so I got my meter here with a thermocouple and stick it in the blast of air, and thermocouple's measuring 900 to 950 degrees or so. When it says it's at 1170, but it might be 1170 and at the elements. Fair amount of heat sink here, so it's going to cool off. See how quickly it cools down. Air temperature dropping pretty quickly. I'm on cooling now. It's actually pretty fast. We're only like 20 seconds in and we're down to 300 degrees from almost 1,000. Now we're down to about 160, 180. Yeah, it still feels warm. Guess there's a fair amount of mass in there to heat it up. Checking current draw here. So with just a fan on, it's about 0.8 of an amp. And if I start increasing the temperature to where the heating element comes on, looks like it goes up to a maximum of 13.3 or so amps, which they claim 14, so that's absolute worst case scenario. So I think they did a good job of staying within spec. It looks like they pulse width modulate the heating element to get a lower temperature. So I'm gonna let this cool off and we'll go to disassembly. Well, I'm reasonably impressed. I'm gonna let this thing cool down and let's open it up and see how decent the build is inside. This was not a very expensive heat gun, by the way. I think, if I remember right, it was on the order of $30-some. So very affordable. Maybe it was slightly more than that. Another interesting design feature, it's been cooling off for about a couple minutes now, is this stand here actually lets it stand up vertically as well. That's a really nice design besides being a hanging hook. That's that's thinking ahead. So we're down to where we can hold on to it. I'm gonna let it cool off a little more and we're gonna take it apart and I'll be right back. All right, this guy's cooled down. It's held together with torque screws. So I'm gonna pull these off real quick. It looks like there are 2 in the handle, 4 in the body. Clamshell design it looks like. All right, got all the screws loosened. Looks like they're all the same size, which is good. I hate the designs where every screw seems like it's a different size. That doesn't do anybody any good. So it looks like it might snap together as well as have the 6 screws. So it does snap together, as you can hear. And I think that they might capture the front and the back of the clamshell. It kind of feels like the amount of force. Nope, actually the back is free. So the front, I don't know, maybe you have to pop the front off first. Let's see. Or maybe it just comes out of the front. There we go. That holds the 2 clamshells together. That's kind of crafty. Okay, pretty straightforward design. Universal motor. Amazing what they can put a microcontroller in these days, right? For such a small price. Get some RFI rejection here from the motor with that ferrite coil. And more RFI with these small ceramic capacitors on the back of the motor there. They did use some Celastic to hold the connectors in for the sensors. So it looks like the sensors go into this part. I really don't want to take apart this housing. It is just plastic and pressed sheet metal, which I think we all expected, let's be honest, for this price range. You can't have extreme quality. It says it's polypropylene with glass fiber 10%, which is nice. That's better than old stuff where there was no glass fiber at all. So it's a very cheap Chinese design, but with a fair amount of thought going into it. Now that's a little disconcerting. So you notice this heatsink here, which what I'm guessing is the driver IC for the motor, probably a DC motor. They left this lead long on the motor, which I am going to trim off right now. And it was within spitting distance of touching that heatsink. Quite often, on a lot of semiconductors, the heatsink, like in a transistor, the heatsink is often the collector, and I think the drain in a MOSFET. So that's a little dangerous. You definitely don't want to do that. It looks like they left long lead from the capacitor on the other motor lead as well. So I'll trim that off before I put it back together. Other than that, it looks like they did a pretty good job. Heat shrink everywhere. It's fairly inexpensive plastic construction, but feels very solid. So they did a good job with the feel on it. Oh, and it snaps in multiple places here. So that adds to the solid feeling of this. So that holds in really nicely. So now it would have just barely cleared, but still I don't like that. It's too close for my taste. So this next part of the clamshell snaps over and snaps in like that. And then this guy snaps over and holds the front together even without the screws. So that's how they get such a solid feel. There we go. How they get such a solid feel out of fairly inexpensive plastic. It's got a nice feel. So all in all, I think pretty good. I give it a thumbs up for the price. Go check out your local your sale at Harbor Freight. I think I got it for something like 39 bucks. So they have multiple models of this like they do with a lot of their series, and this is the fanciest one with the LCD display and the thermocouple temperature measurement built in, which is handy. So you know what internally what it thinks the temperature is. Externally, I think it's going to take a long time to get there because this is fairly thin metal, so it's cooling rapidly. I noticed that this didn't get very hot, only a couple hundred degrees. Which is good because you don't want that to get too hot because it's just fairly close to the plastic. But on the flip side, that's radiating a lot of the heat that's being generated inside.